here. First, we start from the NumPy. I think because for the previous task, I think most of you have mastered the basic uses of your SciPy library. So I don't want to give a tutorial from the very beginning, from scratch, what where the ND array is or something. Here, I just list some problem for you, or question for you about the usage of NumPy. And I will just lead you go through one by one, and very quickly. And make sure you have roughly, or at least roughly question for each answer here also. Sorry, rough answer for each question here. The first, what is NumPy array? NumPy array is a matrix. It could be a matrix, 2D matrix, could be a 1D vector, could be a 1-by-1 scalar, could be a multi-dimensional vector. We call it tensor. Here's the ND array. And how to build an all zero, all one, or random array given the specific size. So I just read the question, so you should have your answer, roughly answer in your mind. If not, I think you have to go back to find answers. And then how to gather a NumPy array from the data file, like txt, like the XI file, and when you have a NumPy array in your computer, how to save it to your data file, like the txt, like the XI file. And given a NumPy array, how to assign a value, specific value of our array. How to modify the value. How to indexing or slicing the array. Means you have a 1-by-10 vector. I want to get the first 5 elements as a sub-vector. How to do that? They call it index or call it slicing. And give you a list data structure in Python. How you just convert the list to the NumPy array. And here are some of the basic questions, basic knowledge of NumPy. I believe most of you really should make it clear to smoothly do your project. And the second part is the for loop or vectorize or forecasting operation. So just regarding how you do such operation, I talked in the basic module, like find, modify, do something. In a for loop, I mean one by one to do this. And how do you do the operations in one line? I mean, use the vectorize or forecasting things to do things. Don't use the for loop, but I can assign some values to an array. Just use one line. Here's for the for loop and vectorize. And for machine learning, what we have to master for the NumPy is linear algebra operation. So give you an array. How to get the size of the array? And give you an array like the 3x3. How do you reshape it? Reshape means 3x3 to 1x9 or something. And how you transpose the array. So suppose your array is a 2D matrix. How do you give you two arrays or two matrices? How to do the matrix multiplication for this? And given two arrays or one array or two vector, how to do the element-wise add, divide, plus multiplication of such arrays. And given an array like 3x3, how does it explain a new dimension of this? For example, like the 3x3, I want to build it I want to convert it by the 3x4. In this case, you may implement it in your linear regression when you have to add the constant feature, maybe 1, to the initial data set, initial data matrix, and just in that case, you don't have to model the B, the bias term, as you have already the constant feature for each data. So here's another expand new dimension for array is used. And give a multi-array like 10 vectors. Each vector is 1x10. How I just concatenate? Concatenate means for this 10 1x10 vectors, I want to be concatenate to a 1x100 long vector. Or how to stack them? Stack them is this. I want to do this 10 1x10 vector to a 10x10 matrix. How to do this in NumPy? And given a NumPy, give your array, how do you get the mean value, max value, and your or median value or something over the OR matrix or OR array? Or I just will get the matrix given specific dimensions. So if you, when we go through all the problems, if you have a very clear, yeah, I know the answers. Yeah, it's great. I think you are, you master level of the NumPy. It can handle most of the machine learning problems. If you are not clear, just paste the question here, search in Google, and check the document. Here, and then here is for NumPy. And we'll spend more time on SciPy. So what is SciPy? SciPy is a fast and stronger Python library for the scientific computing. And what is SciPy's feature? The first feature, just keep in mind, is based on NumPy. This means when you do the computing value, the computing element you want to do that transformation, it should also be the end to the NumPy array. I mean the NP array in NumPy. And the little array, the SciPy is very, very strong. Almost everything you have to use with regard to the computing in machine learning, or just all the mathematical course you have get from the undergraduate has been implemented, all algorithm has been implemented in the SciPy. Like the linear algebra, like the statistics, like the calculus, you want to do the differential, you want to do the integration for the optimization we will talk today, for the signal process. This including or cover all the, I think, basic mathematical computing things you have to use. Not only machine learning, but in other fields. But today we are focused on the optimization module, and because you have to implement SVM in your coming homework, and specifically we are focused the things you have to use in such homework with just this function. We call the SciPy, optimize minimizer. So first we just repeat the SVM problem, or I call it general form of the optimization problem. For example, here's your software SVM. I don't want to go details. But here, make it in your mind, there are 4 parts about our optimization problem. The first is value W. Of course, we want to adjust the value of W and minimize the object functions. And we saw object functions, we have some constraints. It means some function related to the X to the W, you have to make it equal to something, or less or greater than anything. So pay attention, the constraint could be unequal, inequality, or equal to. So it all holds. And in some cases, we have the fourth part, for the bounds. It means like for W, for the weight we want to minimize, we want to optimize. This value should be bounded by 0 from 0 to 1. So actually, the special case of our constraints, but sometimes we just list this separately and do this. So for general optimization problem, we have 4 parts. So it is clear. Yeah. So what about we do these functions? When we check the document about this function, the SciPy optimize and minimize, when you click the link, you will think something like this. For the input, here just list the parameters you want to get the input of this thing. And with string, we just define something very similar. The function, the x0, the bounds, constraints. This just match what we have defined for optimization functions. So if we just look at all the algorithm, this function, this parameter, this document, you're saying, yes, this is very trivial. It means if I just define a function, define x0 means the variable initialization, and define the bounded, define the constraints, and then we have to get in as input and call it a function, and everything's done. Yeah, this looks very trivial. However, it actually is trivial, but it's not such trivial as you thought. Because for the function, for x0, for bound, for constraint, you have some specific format for this, and you can then call it. Now, what's the output? If you check a document, if I want the output about the function, it gives you something like called optimizing result. It's like a very strange class, and you should check document to check how should we extract the optimized value, the object function, the variable you want to optimize from this class. Here, just check the document. And I will give a very simple example here. It's called a box design. Just imagine you have to design a box, maybe a bookshelf in your room. And you have three variables to identify the box: the length, the weight, and the height. And I want to maximize the value of the box. Of course, I want to get more things in this box. And I think I have a limited surface area. Just imagine you have to do some painting on this box, and you don't have enough money for painting to paint this. And we have some constraints. Because imagine the bookshelf I put in your bedroom. This height, this weight, this length could not bigger than anything. And here I get to do the functions. The object functions on top of the value, just the length by weight by height, and surface area is by this function. So does this make sense? Sure. And then we can go to the code example. So we just go through line by line about the box design part that we just talked about. The first, the library we have to use is just two. The first, import NumPy. Oh my God, it's held up today. First, here's the only library we have to use for this. And then we just define the order function. Just given x, we define L, M, W, and H, and we return value. So it's trivial. And then we define a function to compute the surface area. But it's still trivial to follow the equation we just talked about. And then we just define object functions. And then here, because we want to maximize the value. However, the function we use, we call it minimize. So here, the object function should be minus about your value functions. So it makes sense, right? Here's all just very simple object functions. And just we define the constraint of the optimize. I mean, the surface, all the surface should be less than 10. And y should be here. Y and this for just check the document. Very, very simple four functions. And then I just define the constraints. We'll just define constraint functions. However, when you call these minimize SciPy functions, the constraint should be right in something like this. You use tuples to tell the minimize functions. Yeah, the type of all these constraints should be unequal to, and the function itself is a constant function we just defined. And then we just initialize the variables like L, W, H into 1, and I put it together to get an initializer of our variables. So not the product. And then I just define the bounds of variables. Here, record the length, the weight, the height should have a minimum and maximum. And I define bound like before. And what I try to do just here's a minimize function inside pi. The function is your other objective function is defined. The x0 initial state of the variable you want to calculate. And the method is called you have lots of methods to choose. So here use this the special inner square or something, and constraint and bound. And I just input what I defined previously, and just run this, and I got the solution. And you will see what the solution looks like. Solution tell the function value of object function is minus or something, and here to give you the optimal x to design that box. So we're done. So this here is very trivial. Just get your optimized function, define 4 parts. What's your variable, what's your object functions, and what's your bounds, and then just call this function, and you'll get results. Here I have attached code to the slide, so you can check the code in the slides too. Let's go back to the slide. But here, the following example is just for the box design. But in your homework, you are also use these things. There are some tips and challenges for your homework in SVM. The first is use the setting method is the sequential LSOP. So stick it on this method to when you call functions, because this algorithm these methods very stable and fun. And what's the challenge? Challenge means in the box design, we only have the one constraint, is in the surface to less than 10. These are inequality constraints. So how about I have multi-constraint formulas? And what about it's not inequality, or the equality of the constraints? The second challenge is how about for the box design, I have 3 variables. So I just define 3 bounds for this by manually. So consider you have thousands or hundreds of variables to optimize. So how can we just add bounds efficiently for such dozens, hundreds, or thousands of variables? And the second challenge here, I think, is the current for the box design. My object functions, my constraint functions, what I define in Python. The only input, the only parameter result is a variable. However, in SVM or in other parts, your constraint, your object functions have other fixed parameters, like your data. You can see here, so for the SVM, you have the x here for the constraint, you have x here. So x is your data. It's also an input parameter, fixed parameter of your constraint function. How to handle it when you call this SciPy automatically call the SciPy minimize functions. It's a challenge you have to handle by yourself. Here I just give you some hints. The first is to check document. The document is here. You see, there are lots of the variables here, and what we just use is just 4. What's the value? What's the function? What's the use of other parameters? I just tell you with other parameters, you can just define the fixed parameters for your constraint, for your function. And another possible solution is to use something called lambda functions. If you not heard these names, I think you can search it or learn it. It's another very useful tool in Python. And thirdly, like the class method. Here I just give you a hint. Maybe you may just feel confused about what I say here. But when you start doing SVM, this is a SciPy function. You'll get a lot of what you say. And so sorry for today. It's all we have today. Thank you. Yeah, and for the code, I'll just show you when I made some screenshot, and you can check it using this method. Thank you. See you.